Folks, welcome to exercise 6F. We're going to start our theory lesson with solving rate problems. So we did some of the stuff already with rates. Now we're just going to be doing a lot more of word problems with them. So the learning intention for today is to understand that rates can be used to model many situations, and the success criteria is I can solve rate problems. So just to start us off with here is, which job would you choose? Would you do job A, where they pay $735 for 30 hours? Or would you do job B, where they do $822.50 for 35 hours? So what we need to do is, just like what we did last time, we're going to compare two different units of measure with each other. And so the two different units of measure that we have are the dollars and then the hours. So what we're going to do is we're going to divide 735 divided by 30. So that's the dollars there. So dollars and then hours. So that means that's going to be, so if we divide that, be 735 divided by 30 hours. It'll be $24.50 per hour. The second option is you're going to do $822.50 per hour, so 35 hours. So if you do that, it's going to be $23.50 per hour. So with this, it looks like you're going to get less money, the 735. This one you're going to get more money, but this one is actually a better option because you get more money per hour that you work. So that's why it's important to know how rates work when you're comparing two different things. All right, this is actually, we've done this stuff before when we're solving the rate problems. Just like what we had in the last example and last lesson, you are going to be comparing between two quantities. So if one quantity changes, the other quantity must also change with the same proportion, okay? So you're going to have the same rate. And then so when it talks about per hour here, we are going to do it per 1 hour, okay? So every 1 hour that changes, it's going to be $20 that you earn. So therefore, if it's 2 hours, it'll be $40 that you earn, okay? And so the example that it has here is Patrick earns $20 per 1 hour. How much will he earn for 6 hours? So you times this by 6, therefore you're going to get $120. So you times the right side by 6, and so you have to times the left side by 6 as well. Okay. The next one, the other example is Patrick earns $20 per hour. How long is it going to take him to earn $70? Okay. So the worked example that we have here is you want him to earn $70, and you know that he gets $20 per hour. So if you divide that, that will get 3.5 hours, okay? And then so we can confirm that by doing the example that it had here, okay? If you times the 1 hour by 3.5, you'll get 3.5 hours. If you times the 20 by 3.5, you'll get the $70, okay? So that's how we know the relationship between the two different quantities. All right. So you don't need to write these ones down. The only thing that you need to write down is just the top part here for me, because we're going to have the worked examples afterwards. So we'll just take a 1 minute pause here just to get the solving rate problems. Okay. Welcome back. We'll go now to the worked example that we have. Now, we need to make sure always that we highlight the important information when we come to these different word problems. So the step-by-step that we do have though is we need to ensure that the rate is in its simplest form. Simplest form means that it is actually per one unit. So you have the first quantity happening per one unit of the other thing happening, okay? So when we have this, we're saying Rachel, oh, that's my wife. Rachel can type 74 words per minute. So it's per 1 minute here. So that is indeed per, that is the simplest form, okay? 74 words per 1 minute. And then how many words can she type in 15 minutes, okay? So we had here 74 words per 1 minute. And what we want to do is we want to go to 15 minutes. So we're going to times this by 15 and therefore times this by 15 also, okay? So it's going to be 15 minutes. And if we do 74 times by 15, she will have typed 1,110 words in 15 minutes, okay? I'll rewrite this just so it's a little bit clearer. 1,110 words in 15 minutes, okay? The next question that we have is, Leanne works in a donut van and sells on average 60 donuts every 15 minutes. How long is it likely to take her to sell 800 donuts? All right. Now, so for this right here, we know that it is not the simplest form because this one is every 15 minutes. So we have to make it so every 1 minute. So we go here, 60 donuts. I'll say 60D per 15 minutes. So what we want to do is I'm going to divide both sides by 15 because I want to try to get this 15 to 1. So I'm going to divide it by 15, okay? So divided by 15, divide by 15, divide by 15. So then that means it's going to be 4 donuts per 1 minute, okay? So that is the actual, the rate that she does it per minute. Now we want it to see how long it's going to take for her to get to 800 donuts, all right? So we'll do 800 divided by 4, okay? So 800 donuts divided by 4 donuts because she makes 4 donuts per 1 minute. And then that means it's gonna take her 200 minutes to make 800 donuts. Okay, so the step-by-step that I did there was I made this 60 donuts every 15 minutes. So right here to how many donuts per 1 minute. So it's all how many of the first unit compared to one of the second unit. And then after that, I divided what you want to achieve divided by the actual rate per one of the other units. So I simplified this and then I divided the 800 divided by 4. So I'll give you 5 minutes just to do both of the questions on this side. So we'll take a pause right here. Okay, welcome back. So we'll confirm what we did for the you-dos now. So Joanne can type 80 words per minute. How many words can she type in 25? So very similar stuff, right? So we want to go from 80 words per 1 minute and we want to go to 25. So I'll do 25 on both sides, 80 times by 25. So she's going to type 2,000 words in 25 minutes. Okay. Next, a hot dog vendor sells average 60 hot dogs every 20 minutes. How long is it likely to take to sell 210 hot dogs? Okay. So 60 hot dogs, so 60H every 20 minutes. I'm going to get that down to the most, the simplest form. So I'm going to divide this by 20 to try to get it to 1. So divide by 20, divide by 20, which means he actually sells, so 60 divided by 20, he sells 3 hot dogs every 1 minute. That's actually pretty good. All right. And then so you know now how many he sells in 1 minute. You're going to do 210 hot dogs divided by 3. And so he sells 70. It will take him 70 minutes. 70 minutes to sell 210 hot dogs. So give yourself a tick if you got that right. Otherwise, just correct that for yourselves. So we'll go to the next one now. And this is just a really big one, which involves a little bit more steps. But it's still the same process where you want to identify the important information by highlighting it, and then use what you know about the rates, okay? So we'll read this together here. Like it says here, extract the key information, okay? So we have 3 water hoses, okay? We'll see if that's important, from 3 different taps are used to fill a large swimming pool. The first hose alone takes 200 hours to fill a pool. The second hose alone takes 120 hours to fill the pool. And then the third hose alone takes 50 hours to fill the pool. How long would it take to fill the pool if all 3 hoses were used? All right, so what you need to do is you have to try to find each one of the individual rates, and then you combine all of the rates together. So what it had on here is find the LCM of all of the 3 rates. Now the thing that you need to consider here is that rates was 1 unit in relation to another unit. So for here we have the first hose. So I'll say hose 1, so H1. Okay, H1, it fills up 1 pool. And how long does that take? It takes 200 hours. Then you have H2, so hose 2, it fills up 1 pool and it takes 120 hours. So I'll just put the hours here just so then we know where it comes from. And then lastly we have H3, so hose 3, it fills up 1 pool and it takes 50 hours. And then what you need to do is you have to find the lowest common multiple between these 3 numbers. The lowest common multiple, so the LCM, is going to be 600. Okay, and the way that we did that was you just find the multiples of each one, and then what's the lowest with all 3. So it's 600 here. Okay, next we need to put all of them into the same lowest common multiple. So on here it's going to be 600 for hose 1, and to get from 200 to 600 we needed to times that by 3. So you times the top by 3 as well. So it'll be 3 over 600. Next, we had to times, we'll do this 600 again. What did you do to get from 120 to 600? We had to times that by 5. Okay, so times by 5, so you times the top by 5. Therefore, 1 times 5 on the top is going to be 5. And then lastly, we have the third hose. We times 50 to get to 600. We needed to times by 12. So you times the bottom by 12, the top by 12. So then it's going to be 12 on the top. Lastly, you of course have to add all of the top numbers now. So 3, 5, and 12. That's going to get you to 20. So it'll be 20 over 600. And then you just need to simplify, okay? If you divide both of them by, not the 3, sorry, 20, divide by 20, it means that you're going to get 1 on 30, which means you're going to fill up one pool in 30 hours, okay? So I'll give you about 5 minutes to do the you-do. It's going to be very similar here. I know that's a little bit hard to grasp, but the main thing that you need to understand is the first rate is the one pool, okay? And then, so the first part of the rate is the one pool. And then the second part is that it takes the amount of time for each of the hoses. So we'll take a pause here and then I'll give you the time. So 5 minutes, pause. All right, welcome back. So let us go through the second worked example on here. This time you only have 2 hoses. So 2 hoses fill up the large pool. The first hose takes 200 hours and then the second hose takes 150 hours. Okay, how long does it take to fill up the hose if both of them were used? Okay, so let's label it here. We have hose 1. It takes the hose 1 100 hours to fill up the pool. Hose 2, it took 150 hours to fill up the pool. Now, what we need to do is find the lowest common multiple. And so we know that it's going to be, so with this 100, it's 100, 200, 300, and then the multiples for 150 are 150 and 300. So therefore the lowest common multiple is going to be 300. So LCM equals 300. Okay, so we want both of the denominators to be 300. So it'd be 300 and 300. And now what did we do to the 100 to get to 300? We times it by 3. So you have to times the top by 3 as well. So 1 times 3 is 3. What did you do to the 150 to get to 300? You times by 2. So you need to do the same to the top. So it'll be 1 times 2 is 1 times 2 is 2. And then lastly, we add the actually not lastly, second the next step is add the 2 numerators together. 3 plus 2, it'll be 5 on 300. And then lastly now is you have to simplify this. So what's the number that goes in both 5 and 300? Divided both by 5. Okay? And then that will be 1 on the top and it'll be 60 on the bottom. So to fill up one pool, it's going to take 60 hours. All right, so that is the end there. Just make sure that you correct this if you didn't get it right. And then we'll leave the log sheet here as well. Okay, have a good class and all the best.